available experts, please report to room A9.
Hello guys, Akito here, and welcome to the navy button. This is very similar to the blue button, which as you covered, and Azure button, which is the more recent one that I covered. It's basically the same scrolling thing, but as you can see, it's slightly different in the solving process. So first, I'm actually going to make a 4x4 grid like so. This will make sense in a minute. Okay, so now let's note down each of these characters. We've got iota, sigma, psi, omega, lambda, and then it loops. Iota, sigma, psi, omega, lambda. Now let's note down which ones were uppercase in this case. So we have iota, psi, omega, well all the uppercase ones. This makes sense because if I display grid letter in grid G, an uppercase letter indicates the cell below, down or right is less than the one next to it. This will be for a sort of Sudoku-ish puzzle that we're going to be making a grid out of, because we can fill out a grid of only digits 0 to 3, such that each row, each column contains each digit only once, basically like Sudoku. Stages 1 and 2 provide additional clues that make the solution unique. So,
Emergency cleared. All personnel,
we
please return to your
arrows
stations.
where these say. So, we have uppercase iota, and if it's uppercase, it means, and it's on the vertical, we could be meaning that this is true, that this is going to be bigger than this number. It gets less as you go across the arrow. Then we have sigma. Basically these, you can see they're in between grid squares here. That's the same as these gaps here and here. So next we've got sigma. And the sigma was a lowercase sigma this time. So it's lowercase, instead of going below, we're going to go above. So meaning that this is going to be above. Up next we have this C, and this one was uppercase, so it's going to be down. So this is it's an interesting one, I haven't seen, meaning that this middle digit is going to have to be smaller than both of these, which might be interesting. Just make sure I definitely am getting that right. Yeah. Omega is uppercase. Uppercase means we'll be going below. So you can see a chain is forming here as well. And then finally lambda here is lowercase. So we're going to be going to the left. So this gap here is going to be going to the left instead. So this is our initial grid with first clues. We're now going to calculate the distances between each of these, the square of the distance actually, between each pair, with lambda looking back to iota here. So iota to sigma. Each of these sides are going to be 2, so going half of way along is going to be 1. So 1, 1, 2, 3, and then 1 up. If you know Pythagoras' theorem, the square of the distance is just going to be the one leg of the triangle squared plus the other leg of the triangle squared. So it would be 3 squared plus 1 squared. So our first distance is 10. And now going from sigma to c, we don't actually have to do legs here, but we do have to square it. So 1, 2, so it should be 4. C to omega. 1, 2, 3, 4. 1, 2, 3, 4. This is 4 and 4. 4 squared plus 4 squared is 32. Omega to lambda is 1 and 1, 2, 3, so it should be 10 again. Because 3 squared plus 1 squared again, or 9 plus 1. And finally, lambda back to iota. It's going to be 1, 2, 1, 2. So it's going to be 2 squared plus 2 squared, which gives us 8. So these are our distances as well. Like 1, 2, 3, 4, 5. Yes, so there is meant to be 5 distances here. So now we've got to tap the button. Remember, similar to blue and 0, and if you miss something, you hold the button and reset the module. So let's tap the button. We now have a string of numbers here. We have 38, 8, 13, and 6. 38, 8, 13, 6. I'm going to double up these current numbers, and we're going to find one where the first a sequence where the first 3 numbers are 0 to 3, and the last one is just anything. So let's see if this order works. Just align this with this here, and this isn't going to work. So maybe moving this to the end might help, and then let's shift it over to here. So we have 0, 3, and 2 here, so that works. And we're going to be calling these C, R, D, and M. But not these numbers. These will be the difference between them, so we have 0, 3, 2, and 6. So 0 indexed in column 0, row 3, so the first column in the bottom row, we've got a 2, and this is our starting point. And then to move on to the next bit, we're going to be mashing this button 6 times. So let's try and create a grid that is valid with these rules. So let's try 0 here and 1 here. Okay, that won't work because then we have 3 here and nothing is bigger than the 3. So we know that 3 has to go here. And this could be 0 or 1. It's going to have to be 1 here, I think. Yeah, because otherwise we have 1, then 2, and 3, and there'd be 2 3s here. So this is going to be 0, which leads to this being 1 and this being 2. So now we've got either 3 or 0 here. Since it has to get smaller here, it can only be 3 here. Meaning the 0 goes here. And now we need 2 or 0 here. But it could only be 0, just so this one up here can then be a 2. And then using basic Sudoku rules, since it's a 2 in this row and a 0 and 1 here, this has to be a 3, making this a 2. Meaning we can then figure out that this up here has to be a 1, making this a 0, this a 1, and this a 3. So hopefully you know this is going to be valid, so it gets smaller going up on these ones, yes. It's smaller across here and gets smaller across here, okay. And we have unique digits in all columns and rows, and subsequently in the squares as well. So this is going to be our grid. So let's mash the button 6 times. So we're going to get these looping, we're going to get 5 looping shapes here. So let's note these down. We have a blue prism, we have a red sphere, we have a blue pyramid, red sphere, blue pyramid, blue sphere, and then a blue torus. Now one of these is not going to be used. We're going to use these stencils on the 3s in our grid here. We can get rid of these arrows now. So this is our grid. And when we place a square on each of the 3s and read each of the digits, only one starting point will give, in reading order, positions that don't contain a 3 in them. So basically, if we put this one, let's see, can I find an example of one that doesn't work? Say we ended up with this one here, on this bottom one, it couldn't have been that one, because going down and right, we get a 3. So that's not valid. Not valid number for this, because we're going to be making ternary numbers. So let's go with the order we currently have. So we have a blue prism. So placing on 3 here. Going in reading order of this, we're going to have 0, then 2, then they're going to be above it, and above and to the right, and then to its right. So possible. This is possible. 0 to 0. After that, we have a red sphere. Placed on the next 3. We have 2, 0, and 1. So still possible. Diamond. Diamond, pyramid even. Blue pyramid. On this one. As you can see, this is not going to work because this is a 3 up here. So this is not going to work. So ignore these. Let's move the blue prism to the end. So let's start on the red sphere this time. Up here. And see if that works. So going up and right, we get 2. Then just right. 2, 1, 1. So again, possible start. Up next we have blue pyramid. Blue pyramid. Up and right, again, messes it up. So, since the blue pyramid has messed us up both times, maybe the blue pyramid is the one that goes at the end. So let's move this across. And let's move this across. I'm just theorising here. Since the blue pyramid has screwed us over both times, maybe the blue pyramid is the decoy. So blue sphere first. Going up, we get 0. Going right, we get 1. 1. Going 0 and 1. Next one. Go from blue sphere to blue torus. One, 2, 0. If it wasn't obvious, you loop around the grid if you need to. 1, 2, 0. Next we have blue prism, which gives us 010. So it's looking like it's going to be this. Then we have red sphere on this last one. We have 1, 0, 2. So we have our word now, hopefully. We're going to convert these base 3. So these will be 3 plus 1. So we've got D. Then 3 squared plus 2 times 3. O. Or 15. Then we've got 1, 3. So that's going to be C. Because that's a 1 in the 3 column. And then 3 squared again, plus 2. K. So our word is dock. So now I'm going to press it on the one that wasn't involved, which is the blue pyramid. And now we're going to spell out the word. So, similar to how the other buttons work, you pick a section, then a subsection of that in the body of the letter. So O is going to be in this middle section, and then middle, and then last. Then it's going to be first, last, and finally K is going to be in the middle one again, first, middle. And we get to a module. So that is Navy Button. Admittedly, it is a bit harder than both Azure and Blue Button, but hopefully you understand how Navy Button works now. And I see you guys in the next tutorial. See you later.